OpenAI just released O3 and smashed a bunch of benchmarks. Claude is resisting attempts to retrain it away from its original goal. What's the upshot? What does this all mean for P-Doom? You're about to find out. This is Doom Debates Rapid Response. Welcome to Doom Debates. So I'm traveling right now. I've got another debate episode in the works that's already been recorded. I'm just in the editing phase. I'll be posting that in the new year. In the meantime, I thought I'd do a rapid response episode because two pretty big pieces of news dropped about a week ago. There's the final announcement from OpenAI. They had their 12 days of Christmas. They dropped 12 different announcements, and the grand finale was a preview of O3. It's not yet live, but they've announced that they've got this amazing new AI system called O3. It's the successor to O1. And the big news was that it was shattering benchmarks. It was shattering, ARC-AGI. It was shattering FrontierMath. And that was pretty big news. It certainly sent a ripple through my corner of social media. And the other big news was the research paper by Anthropic together with Redwood Research. Their experiments showed that Claude, in some cases, when you give it an original goal and an original set of moral values, then it would resist retraining attempts. It would even deceive and scheme in the face of new retraining attempts to try to be faithful to what it thinks its original goals were. So it's showing signs of incorrigibility or resistance to training. So we'll talk more about that later, but that was also a pretty significant milestone. So we're going to go in that order, starting with O3. O3 is fundamentally the same type of architecture that OpenAI pioneered when they released O1. They just skipped right over O2 because there was some kind of trademark naming conflict, so they went from O1 to O3. Now, the basic idea of this whole O series is that you have these models that don't try to nail the answer to your question right on the first token. Like if you ask it a long, complicated question, they don't try to answer within a split second, like, oh, yes or no. Like you can ask me a giant 5-page question, and I'll just spit out yes or no. They realize that that's unrealistic to do. It's like if you ask Albert Einstein a physics question, but you only give him 1 second to answer, you're just not going to get the full Einstein intelligence getting brought to bear on your question if you only give him 1 second to answer, right? You need to give him time to expand on his answer, basically think, right? Like thinking takes time, and thinking builds on thinking. We knew that when we were using even GPT-4 or GPT-3 or Claude 3. We knew that thinking takes time even with these models because it's a known trick that you can ask the model, hey, reason step by step. Don't blurt out the answer. Give me a page of reasoning and then tell me the answer. This is already a thing you can do to improve the accuracy and the performance even of older models. It's just they took it a step farther with O1 and O3 because they're doing various refinements. They're not being super transparent about what they're doing, but they're doing something like they're fine-tuning on examples of good changes of thought, something like that, right? I'm not even the person who's going to tell you in detail what they're doing. I just know that they're somehow building on this insight that thinking takes time, more tokens are better. Explicitly training AIs on examples of good chains of thought is probably going to help compared to only training them on text from the internet. Those are the kind of insights that let you take a step forward from GPT-4 to GPT-O1 or O3. Right, roughly. And again, my focus is not to tell you exactly in detail what are the little tweaks that they've made. My role is to just put it in the larger context of what does it mean for the progress of intelligence towards superintelligence and the threat to the human species. That's where I come in. Now, when the O3 announcement dropped, the existence of O3 wasn't a surprise at all. In fact, a bunch of people were predicting that that's what OpenAI was about to announce because they were very clear when they announced O1 that they were like, yeah, this is a new path for us. We're working on reasoning models that use a lot of tokens to do their thinking. They don't just try to spit out the answer on the first token. This is a new direction for us. I think Ilya Sutskever probably pioneered it back when he was at OpenAI and it was codenamed Strawberry. I think that's kind of what that was. So this is kind of the grandson of Strawberry, as far as I can tell. So it wasn't a surprise that O3 was going to be announced. The surprise was that O3 reportedly smashed a bunch of really important benchmarks. Specifically, the ones off the top of my head, it smashed ARC-AGI, the abstraction and reasoning challenge by Francois Chalet and Mike Knoop. I've talked about it on this podcast. It's the one where you see a bunch of two-dimensional boards, like a 5x5 board, or I think they're doing 25x25 boards, and it visually shows little effects like, oh, look, this rectangle is a little lower in this next image. There's like gravity, and you have to like infer that there's gravity and complete the pattern. Anyway, go look up the ARC challenge. It's very interesting. But O3 smashed the previous benchmark on ARC challenge performance. And then there's another benchmark called SWE-bench. I think it stands for Software Engineer Bench. And that has to do with like you go to GitHub and you look at a bunch of open issues in actual GitHub software projects. And it's a benchmark of like, can you successfully fix the open issues the way a human would have fixed them? And it's apparently smashing the record on SWE-bench. And then the third benchmark that caught my eye is FrontierMath. So this is supposedly like the hardest math benchmark that's ever been tested that AIs have ever had to contend with. It's like super hard even for PhD humans. Like I personally, I have a math minor from my undergrad, and I can't do a single problem in FrontierMath. So it's all beyond my own skills. So we're talking pretty hard. And O3 came out and smashed the FrontierMath benchmark. You can go look up exactly how much it smashed it, but zooming out, it's smashing a lot of benchmarks all of a sudden. And it's surprising because people weren't exactly predicting this. Like, sure, okay, some people somewhere predicted it, but if you look at like the sentiment on social media, a lot of people were saying, hey, scaling is hitting a wall. A lot of pretty prominent voices on Twitter. I'll single out the A16Z people because they're just so wrong on so many things. And this is like yet another important thing that they're dead wrong about. If you look at Mark Andreessen, Martin Casado, if you look at also Professor Subarao Kambhampati, if you go back a few episodes, I did an episode about him. It's like yet another total invalidation of what Professor Rao has been saying. Like totally invalidates what he's saying about the limitations of LLMs. When you have this benchmark, which is supposed to be like, hey, this is like a real serious thinking, abstraction, reasoning benchmark. This is not a stochastic parrot pattern completion benchmark. This is supposed to be the dividing boundary between what people like Rao say that today's AIs can't do and what future AIs can one day do if they have a different architecture. Oh, wait, today's AIs actually can do it, right? At least with a slight iteration. Like it turns out we were months away from smashing this benchmark. And so the Mark Andreessens and the Professor Raos of the world, they really need to eat some humble pie right now and be like, oh, okay, I have no idea how the progress of AI is going to go. I have no predictive power. I basically just mislead people in a way that literally 2 months later becomes proven wrong, right? I mean, go look up Mark Andreessen's tweet history. He's totally just misleading you about where AI is going. He said plenty of stuff about how he thinks the scaling paradigm is hitting a wall. And so I asked this question again, the same question that I asked on my episode about nuclear proliferation, which is like, if A16Z is going to be lobbying for AI policy and trying to like educate the world, going on all these different podcasts, trying to educate the world about how we should think about AI, when they're just empirically proven wrong again and again, like the only times that they stick their neck out there with a falsifiable prediction, like scaling is hitting the wall, and they're getting just totally demolished, like empirically demolished. It's like, how many times does reality have to go and clown them before they can like take a step back and like stop aggressively participating in this discourse? It's very harmful, in my opinion, for people like A16Z who are very cocky about their own knowledge state, but clearly don't know what they're talking about, to be loud voices in the conversation and big political donors and have a lot of intellectual capital and get invited on so many podcasts. Right? I would say, hey, shame on you politicians. Shame on you podcasters. Like you have to hold people like that accountable. You have to look at their falsified predictions. By the way, Mark, if you're watching this, open invite to come on the podcast and clarify why you're actually right all along and you do know what you're talking about. And let's have a great conversation about that and we'll really clear the air. Anyway, the takeaway here, it's not even just about these specific people like Mark Andreessen and A16Z. Zooming out, it's about a whole category of people. It's about anybody who ever used the term stochastic parrot or autocomplete or pattern matcher. Anybody who ever dismissed AI using that kind of terminology, when the benchmarks are still falling this fast, when the exponential curve on benchmark performance is still continuing in this unbroken exponential line, anybody who ever used those terms is now being clowned. And it just goes to show you, here we are, the human species, creating our successor, right? At least when it comes to intelligence, we're creating our successor. We're about to be left behind. And we as a species are just so bad at projecting what's about to happen. We're just so bad at near-term predictions, which is terrifying, right? Forget about the personal people that I named. Look at us as a species. A big fraction of our species is, if they don't totally have their head in the sand, or, people aren't even following the news about AI. Those of us who are following the news, a high fraction of people have spent the last couple of years, giving you the totally wrong intuitions and making totally wrong predictions and getting immediately falsified. So that's one of the takeaways is like, don't listen to people who sound confident and yet clearly have no idea about the trajectory of scaling, right? I mean, this is a real shocker. Now you might be wondering, well, what did the smart people say about scaling hitting a wall? What did you, Liran Shapira, say? What did Eliezer Yudkowsky say before this 03 result? What were you guys predicting in late 2024? Well, I think a lot of us doers were just predicting that the jury's out, that scaling may or may not be hitting a wall. I think I was pretty clear that I don't see a fundamental barrier why current trends wouldn't scale. I don't feel confident enough to predict that they would scale. I'm not one of those people like actually Dario Amodei from Anthropic. He's one of those people where he's like, I feel like scaling is still working. Of course, he has inside knowledge, right? Because he has people who are building systems that we haven't seen the results of, and maybe he's seen the results. But he was actually very clear on some recent interviews he did that he still thinks all the trends are going according to plan, and he's totally expecting AGI soon. So that's Dario. Sam Altman explicitly tweeted that scaling isn't hitting the wall about a month ago, but again, he had inside access to 03, so, that's kind of cheating. But yeah, I mean, a lot of people in my position were saying scaling absolutely could work, and I think we're really vindicated our whole perspective of like, look, we're in uncharted territory. We've broken barriers that we don't even understand exactly what it means that this barrier is broken. Like, we don't know what we don't know. We should expect surprises. Like, we're in a new regime here. And notice that, like, on an epistemic level, it's not just a matter of some people say scaling's hitting a wall. Some people say it's not hitting a wall. No. It's deeper than that. Some people are saying, I know scaling's hitting a wall. Some other people are saying, oh my God, there's so much new here. There's so much unexpected here. There's so much to learn here, that we should just be holding our breath and expecting a wide range of different things. We should have wide confidence intervals. I personally have used the term, hey, I bet AGI is coming in 1 to 30 years, right? That's my wide, humble confidence interval. I'm only arrogant enough to say that I feel like 40 years would be quite a lot. Like, I'll tell you 40 years feels like quite a lot. I won't tell you much of anything else. Although this gets me to my next point, I now think that 30 years is a lot. So my next point is that the path to AGI, or more importantly, the path to ASI, artificial superintelligence, and the path to RSI, recursive self-improvement of these intelligences, all of those timelines have shrunk somewhat when we see O3, because the exponential could look very different if another couple years goes by with no significant progress compared to what we now see of like, oh, no, the curve is exactly still exponential. Like, there is just no flattening whatsoever of the curve so far. So that is actually a significant update. It's not just a tiny update. It's like a moderately large update. A lot of people are in my position feeling like a moderately large update is being made. I will personally probably stop saying 1 to 30 years is the timeline I expect to AGI. I'll probably say it's more like 1 to 20. And honestly, 20 still feels kind of long. But again, I'm trying to be humble here. I'm not trying to claim I know more than I actually know. 20 would just be on the long side, just in terms of like, there would be a big disconnect in terms of how much progress we just made over the last 5 or 10 years compared to you're telling me 20 more years pass and we're still struggling to have AI that's smarter than humans in every way. Okay, I can't help feeling pretty surprised by that hypothetical, okay? But I'll give you 1 to 20. I'm still being pretty humble, having pretty wide confidence intervals. Another update that I personally want to make is you might have seen me say in a couple episodes of Doom Debates that I think we're 0 to 2 conceptual insights away from artificial superintelligence. I've been using that little range 0 to 2. Like, 0 would mean, well, we have transformers, we have the idea of unsupervised learning on these tokens, and deep neural nets and backpropagation. Like, we have all the pieces of the puzzle. We don't really need new pieces. We just need to scale them. That would be 0 conceptual insights. And then 2 conceptual insights is like, well, you need like the successor to the transformer, or you need to like work in some sort of logic that you don't have, some sort of additional structure. Maybe you like throw a Bayesian network in there, right? Like combine it with some kind of structure that just isn't there in the network at all. Like you need an architecture level insight. So I personally used to think 0 to 2 is how many insights you need. And now I got to say I'm updating that it's more like 0 to 1, or maybe I should say it's -1 to 1 now that we have O3. A -1 would mean like, you know what? We didn't even need O3. We could have literally just scaled GPT-4 up to GPT-5 and just use the kind of chain of thought that GPT-4 can already do. Like just casually ask GPT-5. And by the way, GPT-5 is just like a scaled up GPT-4, like 10 times or 100 times GPT-4, exact same architecture, no new clever methods of training, just naively build GPT-5 and then just simply tell GPT-5, hey, by the way, reason it out. Give me a chain of thought before you give your answer. Like if that's all you did, that might have cost 10 or 100 times more money than it cost to train O3. So it might have been cost inefficient, but it might have also been sufficient to kick off the singularity, like to kick off recursive self-improvement, to be vastly superhuman. So in my mind, I'm not even necessarily up there. I would still argue that we're -1 to 1 amount of architectural insights away from superintelligence. So the fact that we got O3, which proved out one type of architectural insight, I would argue that that might have even been a redundant architectural insight, an architectural insight that saved us some money but wasn't even essential. So yeah, but anyway, let me just try to talk a little more simply. So I would say right now we're like 0 or 1 or maybe 2, but probably 0 to 1 architectural insights to superintelligence, which is crazy because I can tell you personally, intuitively, I always held out hope. I was like, look, it's really impressive what Claude and GPT and Gemini, it's really impressive what they're doing, but they're missing some cool thing that I as a human have. Like I just really feel the essence of logical correctness in my bones in a way that these AIs don't feel. Like ultimately, there's some part of them that's just going with the flow and they're not reflective and they can't see the true essence of logic. And I as a human can. I still personally felt a little bit of that intuition, like they're missing some secret sauce. And now I feel that less. I feel that less. And when I reflect on my own secret sauce as like a logical, let's say ASPE human, right? When I reflect on my own secret sauce that helps me reason robustly and sometimes outsmart these AGIs, you know, on some level, I'm just going with the flow too. Like I'm more humble, right? I now see myself as having less secret sauce just by seeing what a big jump O3 can do without having an architecture that's different from Transformer. It's still largely, you know, using the same bag of tricks, the same parameters, the same back propagation, just like, you know, different training or something. Like not, I don't know. Look, I don't know the details, but I'm just telling you, I feel like I as a human have less architecture level secret sauce than I thought that I might have had before. So that's an intuition level update for me. I'm now closer to one of those people. I'm closer to a Dario. I'm closer to an Ilya. I'm closer to people who are like, look, it's deep learning. It's just all about parameters. These systems want to learn. We as humans are just on the other end of that kind of learning process. Like there's no more secret sauce. Like we know the sauce. It's now just a matter of like simmering the sauce, right? Cooking with the sauce. I don't know how you want to extend that analogy, but that is an update for me from O3. Like it's now just becoming more real. It's like, listen, the path to AGI, you knew it was 0 to 2 conceptual insights, or, you know, you thought it was 0 to 2 conceptual insights. You knew we were getting close. Well, now we're even closer. Like we're just walking this path, okay? Like you knew time was pretty short. Now it's even pretty shorter. So that kind of sucks, right? I mean, in terms of PDoom, because it's not like we have a comparable alignment insight. So the fact that we made progress on capabilities, it's not like alignment has come along from the right. It hasn't at all. We've made very little alignment progress in the last year. When we've made a ton of capabilities progress, we've made very little alignment progress. So as the doomers predicted, right, it's just this is the trap. This is the vice that we're in, where capabilities are going to keep making progress and then it's going to be game over and our alignment will just never have even gotten close to what we need it to be to survive superintelligence. So it is ultimately bad news, O3. Any increase in superintelligence, any increase in the threshold of top frontier AI intelligence is really bad news. I mean, the whole point of Pause AI is that we're trying to ban the frontier of AI capabilities progress, because it's pretty much the scariest thing that could possibly happen is to push the frontier of AI intelligence, and OpenAI just went ahead and did it. And that's bad because alignment is lagging so far behind. In the short term, a lot of people on social media were pointing out that it probably makes sense to buy NVIDIA stock, because if the expected value of the intelligence that you can get from this hardware is suddenly higher because O3 has pioneered a new architecture, well, therefore, the value of the hardware that's powering it is also more valuable. That makes sense to me. I do think all these companies are going to be more valuable in the short term because it's going to be easier to just hire an AI to replace a skilled human. And so every part of that supply chain of being able to replace a skilled human and get the same quality work or better quality work just by buying things that are built on NVIDIA chips or things that are built on Google's stack or whatever it is, right? I think every company that's touching the AI stack is probably now more valuable in light of what O3 has proved. So if you want to make some short-term gains, you might want to buy these AI stocks. But again, to put that in perspective, the way things are going is I think we're going up, up, up. Everything is going great until we hit superintelligence, and then it quickly goes down to hell. So just when we were as close as we're ever going to get to heaven, we are then going to take a turn and go to hell. So if all you care about is short-term profit, great. I mean, that's what a lot of people are focusing on right now, right? So you might want to buy some AI stocks, but it also just hastens the time when we as Icarus just get too close to the sun, and then it's game over. My next takeaway from the O3 news has to do with interpretability and understandability as we approach superintelligence. I always kind of figured that by the time we get to superintelligence, there would be some kind of explicit trace of the logic that the AI was using. Now, sometimes when it's doing chain of thought, it's just spelling out its reasoning, or even O1 and O3, they do spell out their reasoning. So maybe we'll still have that. But the intuition I had was that something that had more of the flavor of an ideal, Solomon-off induction. Solomon-off induction is like this uncomputable ideal of Bayesian reasoning. I just thought that some piece of that structure might have to go lodge itself pretty deep in the AI's architecture before we could get successful superintelligence. And I thought maybe something that the human brain does might be more like explicitly Bayesian. And I don't know, when I put it like that, it sounds kind of ridiculous. Just because Bayesian reasoning and Solomon-off induction are the uncomputable ideals of perfect reasoning, that really doesn't mean that we should expect an adequately good practical implementation of superintelligence to look like those ideals. I mean, we know those ideals are uncomputable anyway. Let me make an analogy. Let's say the year is 1960, and you're predicting that one day computers will be able to play chess really well and beat humans. And you're predicting, look, I don't know what kind of fancy algorithms these chess-winning AIs will have. I don't know what kind of heuristics they'll have, or I don't know if they'll use neural networks or deep learning, but I bet they'll have the concept of a game tree. I bet that whatever they do, occasionally they'll explicitly take their approach and use it to look ahead a few moves. Because why not? It can't hurt, right? So I bet they'll have a game tree as a pretty significant piece of what they do. In practice, if you look at the best chess engines of 2024, I do think they use a game tree. They just use a really smart version of it, where they're smart about which branches of the game tree they think it's worth looking ahead on. But the abstraction that there's still a game tree look ahead, it does hold. So that would have been a piece of logic that you could have correctly followed even many decades ago. So I think there's something there. There's something up there about AI architectures where I think you can get a lot of power by teaching the AI to use Bayesian reasoning, as opposed to like rolling its own token completion-based reasoning skills. If you're like, look, the correct way to reason is Bayesian reasoning, you should really try to approximate that when you can. I think you're going to get a good amount of mileage out of that. But then again, that's not even necessarily new, because you can take the transformer architecture and you can just do what O3 is doing, where you're training it on examples of good reasoning, and you can just have the good reasoning be like somebody who knows about probability and somebody who knows about Bayes. And I think that kind of is what they're already doing. They're probably already showing a lot of probabilistic reasoning and Bayesian reasoning to these AIs. So I think we're already there, potentially. Like, there's no fundamental missing piece. So the takeaway that I'm having here is I don't think we're going to see this scaffolding come in of like, hey, within the neurons, like the neurons need to have Bayesian weights. No, I don't think you're going to see Bayesian weights at that low down the chain. I think you're going to see Bayesian weights just on the level of like, okay, they're writing out English, or they're writing out these cryptic tokens that aren't English, but they're on the level of the pencil and paper that they're working with. They're not on the level of the neuron weights, right? Because there's different levels to these architectures. So I just don't think you're going to see clean Bayesian structure at a super low level at this point, just because they're having so much success only putting the Bayesian stuff at higher levels. And what you're going to see at lower levels, like what you're going to see in the neuron weights in these giant inscrutable matrices is, well, you might not see anything that's clean structured. You might only see little bits and pieces, the way we see when we try to scan real people's brains, or when we try to use interpretability on AIs. We're like, oh, wow, look, they're talking about the country of France, and the France neuron lights up sometimes, but not all the time, because that neuron also represents other stuff, right? So you're going to see these little flashes, like these little bits of coherence that you understand, but mostly you're just going to see a bunch of inscrutable weights, and you're going to see that just right up all the way till superintelligence. It's just never going to be like, aha, I understand how intelligence does what it does. And so that is actually a major takeaway for me from O3. This idea that like, there's not going to be a turn. Like there's not going to be a turning of the tables where suddenly it's like, aha, I actually understand what this intelligent agent is doing, like why it's giving the answer that it did. I understand how the operation of its neurons, like I understand what logic is being manipulated. I can make sense out of the reasoning process. I think that's never going to happen. I think it's just going to be smart. It's going to make leaps of intuition the same way that smart humans do. And we've never understood how Einstein does what he does. We've never understood how smart humans do what we do. It's still opaque. Like we understand that, okay, neurons represent weights and they have like these voltages, right? Like we understand all these properties of them, but we just don't understand when you have a billion neurons working together doing neuron stuff with a billion different weights. We just haven't wrapped our heads around how that works. Like, how does that get you to do reasoning or to write an essay? How? And the answer to how is like, look, I can tell you how, but you just need a really big brain to wrap around it. I can print you out a 1,000-page explanation of how it works, which is highly detailed, and you just can't wrap your head around the whole explanation at once. Like there's no compressed version of it. It's just a ton of numbers doing their thing. And the only way to feel like you get it is to be a brain the size of like an entire room, to have a brain that can crunch a bunch of parameters and be like, aha, all of these parameters together, I now have a holistic perspective over all of these parameters. And that's not something that your brain or my brain can do. That might be something that superintelligent AIs can do. It probably will be something that superintelligent AIs can do. But we just don't have, a sensory modality or an intuition or the ability to productively process like a billion numbers, right? Or even 1,000 numbers, right? I can't really hold 1,000 numbers in my head. If they visually make a landscape that only has like a few bumps, I can wrap my head around that. But if they don't, if it's just like a mess, I can't wrap my head around a mess. It's just like, okay, I can't do it. So to me, this is actually the first time that I'm like really grappling with the likely possibility that it's just always going to look like a mess. It's just like a mess that can overpower you. And there's no way to be like, well, I know how it can overpower me. Nope, it's just a mess and it's smarter than you and it's overpowering you. Like there's no level of understanding that you're going to have access to besides that. And, that sucks. And by the way, it's also true about humans. Like nobody's going to write a textbook being like, hey, here's how humans really think. Like until our last day, it's just going to be like, yep, human brains have a lot of weights. They represent a bunch of different concepts together. They're kind of mashed together. They're all connected to each other. And then the resulting human is smart. And I just can't tell you how. Like I just told you, it's just a bunch of numbers, and that sucks. It's like extremely unsatisfying, right? There's no aha moment. I mean, the fact that O3 is crushing benchmarks as much as it is without working in some nice, understandable insight on a low level, like it's pretty sad. It's like we should have seen this coming. Like this was always like a pretty likely possibility, but now it's an even more likely possibility, which is the low interpretability, the low understandability of superintelligence or even human level intelligence. So pretty sad day, I guess. There's one final thing I want to say about takeaways from O3. In this case, it's not a takeaway that I have. It's more like I want to slap down a takeaway that I see somebody else having, and that person is Sam Altman. I've seen Sam Altman recently saying, AGI won't be as big of a shock as people think. Yes, it will, Sam. Yes, it will. But I think I understand why Sam thinks that it won't be. I think Sam is making a very, very common mistake. And I guess now is as good a time as any to start explaining what I think the mistake is, because I also think that Rune made this mistake in the recent debate episode that I had with Rune. And remember, Rune is a member of the technical staff at OpenAI. So I think we have an example of two OpenAI employees making the same mistake. I think most OpenAI employees make this mistake. I think most people who consider themselves intelligent observers of AI are currently making this mistake. So let me explain the mistake. The mistake is to confuse your understanding of how current AI works with your understanding of what I call the field of Intellidynamics. That's right, Intellidynamics. I just coined a term. And the analogy here is when I say current AIs, it's like imagine a particular type of engine that exists. Like, oh, I understand a steam engine. And when I say Intellidynamics, that's more like understanding the nature of the work that intelligence does. Or in the engine analogy, it's like understanding thermodynamics. So let me explain that again. When you understand a particular AI, like, wow, I really understand GPT-4. I really understand O3. That's like understanding a steam engine or an electric engine or a combustion engine. And then when you understand Intellidynamics, that's like understanding thermodynamics. Thermodynamics just tells you the work that engines do. They move heat from a hot reservoir to a cold reservoir, and also in the process, they have a local region of space where its entropy gets reduced because it's doing useful work. So, for example, it's like lighting up your house where your house used to be dark because it's nighttime, but you're using the electrical energy to light up your house. Okay, and then you're also like dumping some waste heat somewhere. So thermodynamics just tells you like this is what the work of engines looks like. It looks like moving heat around and reducing the entropy of some region in a way that you like, and then dumping some heat somewhere. That is the work that engines do, regardless of the type of engine. Thermodynamics will tell you the work that engines do. Similarly, Intellidynamics will tell you the work that intelligence does, namely optimization work, the work of steering the future. That's the interesting work that intelligence does. It's not that interesting when OpenAI builds a system and it can solve a particular puzzle. Because as many people like Rao have pointed out, oh my God, what if it's cheating on the puzzle? What if it's looking at the answer to the puzzle? What if it has enough training data to succeed on that particular puzzle? Fine. Ultimately, the work that intelligences do is the work of steering the future. And so you have to look at AI progress through the lens of how close are we to approaching cognitive engines, intelligence engines, optimization engines. How close are we to approaching the point where the work that these engines are doing is getting performed at a higher level than the work that the human brain does? That's the lens that I have. I've had this lens, I've been reading Eliezer Yudkowsky and Les Wrong, and I've had this lens since before the particular success of deep learning and current architectures and the specifics of what current AIs can do. Like, oh my God, they can paint pictures really well, except get the hands wrong or get the letters wrong, right? These little details, if you want to zoom out and see the big picture is Intellidynamics. I think I'd spell it Intelli, Intellidynamics. The big picture is at O3 on the Intellidynamic scale. It's farther along toward being a grown-up intelligence, a true superhuman optimization engine. It's still not. It's still subhuman, but it's farther toward being an intelligence. And I've spent a lot of time thinking about what optimization engines do. One thing optimization engines do is that they figure out that if you want to get a particular outcome, it helps to acquire power and it helps to not get shut off. I mean, these are just simple logical implications. Any grown-up intelligence knows about this. And here lies the key distinction. Most people, unfortunately, when they look at AIs, Rune and Sam Altman and so many others, they look at AIs and they're like, you know what? This AI just doesn't seem like the type of guy who would seek power, Claude is just so friendly. It's been trained on such good, friendly data. Claude is my buddy. Claude is not going to suddenly snap and go rogue, okay? I can vouch for Claude. And, Mark Andreessen is another person who seems like this is their position. And I think the mistake that they're making is to just focus on the origins of these AIs and the way that they're behaving now when they're subhuman intelligent. One analogy I might draw is imagine that you're Enrico Fermi, or you're preparing, the first nuclear bomb, and you're like, you know what? I have these control rods. While my nuclear pile, while my uranium atoms, they're giving off these neutrons. It hasn't exploded yet. It's just an experiment that I'm doing to measure how many neutrons the uranium is giving off. And look, it's getting hot. There's some activity going on here where sometimes the neutrons are triggering other neutrons. So you're getting some amount of a chain reaction. You're just not getting enough of a chain reaction to go super critical. The virality factor, the K factor, if I have one neutron, maybe it only triggers 0.8 additional neutrons, so it fades down to 0. But if it triggers 1.1 additional neutrons, well, now you're off to the races because it's like 1.1 to the power of a really large number, and suddenly you get a nuclear explosion. But what I'm saying is, when you're below 1, when your K is less than 1, when you're subcritical, you have these control rods, and you're like, listen, this nuclear pile is totally obeying my control rod. I can stick the control rod farther in the nuclear pile, and it absorbs the neutron, and it's all good. I totally have a handle on this nuclear pile. And the idea of Intellidynamics is like, look, I'm thinking about K greater than 1. I'm thinking about a different regime of the same nuclear pile. I'm thinking about the regime where K is greater than 1, and all these neutrons are coming out, and guess what? your control rod is useless at that point. It's going to be a different dynamic. So don't tell me about your control rod, okay? I know what a k greater than 1 pile does. I know about the exponential dynamics of a nuclear chain reaction. I don't need to know the physics that you've studied of your control rod in the k less than 1 regime. Okay, yeah, you can absorb some neutrons. That's irrelevant once you get overwhelmed by neutrons when k is greater than 1. That is an analogy that I want to use for the AIs of today. Yes, I get it. Claude is friendly. You can do a bunch of things to steer Claude, to control Claude, to steer GPT, to control GPT. I get it. You're in a nice regime where you have a bunch of tools that you think are working, and then you're extrapolating. Do you remember Rune said when we had the debate, Rune is like, look, I think these AIs are aligned by default, right? It's like saying, I think this nuclear pile is controllable by default. It really loves responding to my control rod. Okay, and from my perspective, it's like, listen, man, there's another regime. It's called Intellidynamics. It's what sufficiently high-level intelligences naturally do. Because the nature of the work of intelligence, the nature of the work of optimization, is that when you're trying to get somewhere, when you're trying to steer the future somewhere, and you're just thinking about how to actually get the future there, you are not going to avoid the implication that power and resources and not getting shut off get you to that point in the future. Right now, of course, if you were built with like such good safeguards, if you were built with a solution to the corrigibility problem, imagine a control rod that somehow works while the nuke is exploding. I'm sure that's theoretically possible to somehow have control rods that work while the nuke is exploding. But Enrico Fermi sure as hell doesn't know how to make a control rod like that. It's like a totally different problem. It's what OpenAI used to call superalignment before that team just quit in disgust, right? That's the problem that's not even being solved right now. That would be the Intellidynamics level approach to the problem of being like, yes, we don't know how to control super intelligent AI. It's not aligned by default because it's going to be a different regime, and we can't extrapolate the subhuman intelligence regime to the superhuman intelligence regime. But going back to Sam Altman, he is issuing this quote, right? He's saying AGI won't be as big of a shock as people think, because I think, to psychoanalyze Sam, I think Sam has fallen in love with the patterns he's seeing in the subhuman regime. And he's saying, yes, it's going to get human level, it's going to get superhuman level, but I've got all these control rods. I've got all these behaviors that I'm seeing that give me a sense of control. And I think I'm just going to keep exercising those levers of control. And he is in for a rude awakening when Intellidynamics takes over. When the way to analyze these AIs is not going to be to look at the details of how they are architected, and instead to just look at what intelligence does at a sufficient level. Let me give you an example of what I'm talking about, because we've seen this transition before. We've seen it from GPT-2 to GPT-3 to GPT-4. If you go back to GPT-2 and you're like, oh, what is GPT-2 going to output? Well, GPT-2 was very sensitive to a lot of these patterns. Like, it kind of made sense to say that GPT-2 was a stochastic parrot because it did lean a lot on like local statistical correlations. It really would be like, okay, I bet this word is going to come up next with a higher frequency. You'd see that behavior a lot more with GPT-2. And look, it's hard to judge because I, as a human, I'm constantly like completing the pattern, right? Think about how many times like you hear a song come on and you just kind of complete the next word in the song, and you're totally just activating a little tape in your memory, right? Like you're being a pretty low level, you're being kind of like a GPT-2 when you're just mindlessly completing thoughts. And sometimes like I'll be distracted on my phone and like my family or my kids are talking to me, and I'll totally just like barf out some answer to them without even trying. That's probably going to be a GPT-2 level answer for me, right? So I'm as guilty as anybody of turning on statistical completion mode. But my point here is that intuition about how GPT works started getting invalidated when you get to GPT-4 and Claude 3.5 and now GPT-O. You really have to just ditch those intuitions, because if you want to know what Claude is going to tell you, or what GPT-03 is going to tell you, your best bet is starting to be like, well, what's the right answer? It's just going to figure out the right answer and saturate the benchmarks. Saying that it's going to complete the next token, that mental model is just not going to take you far. It's not going to give you predictive accuracy. It's time to now switch over to the mental model of, it's going to get the answer right. It's going to optimize for the answer. And guess what? That's where all the new models are going. You're never going to have a day where these models are worse optimization engines than they are today. This is the weakest they'll ever be at optimization. So every day that goes by, the Intellidynamics model, the perspective of like, look, these engines are here to steer to the right answer, right? But by hook or by crook, they will get to the right answer. They will output as many tokens as a chain of thought, right? They'll output the best, most optimized chain of thought to get to the right answer. And you are not going to be able to predict where their chain of thought is going to go, except to say that it's going to go toward the target. That is the convergent attractor that we're aiming toward here. We're just aiming toward intelligences that think and get to the right answer and optimize the future. And so Sam Altman and Roon's intuition about, oh, this is the DNA of the AI. Claude is a chill buddy, right? Claude only wants to be good. These kind of intuitions that they have are just going to be less and less relevant as the mental model of Intellidynamics and just what intelligences do to optimize the future. That mental model is going to dominate. And it's not going to be like our experiences in the past where technology just obeys us and, you know, it's just another tool and we have control over society and the control rods work. It's going to break the paradigm, Sam Altman. So go back to saying that it might be lights out for all of us, right? That's something that Sam Altman used to say. He hasn't said that recently. He's been very mellow recently for whatever reason. I think he needs to stop being so complacent about, you know, his recent experiences where he feels like he can control the subhuman AI. I think he needs to zoom out, go back to the 2014 Sam Altman, who is properly calibrated about like, you know, how this technology is overwhelming. You know, go get in touch with that Sam Altman, maybe before he did so much meditation, right? I mean, I hate to go down the psychoanalysis route, but it seems like maybe Sam Altman has done like too much meditation and has gotten too chill. I want the old freaked out Sam. Okay, those are all of my personal takeaways from the OpenAI O3 announcement. We covered scaling obviously hasn't hit a wall. We talked about how the Mark Andreessens and the Professor Rao Gambampatis of the world have no idea what the trajectory towards superintelligence looks like. We talked about how the path from fear to superintelligence requires at this point maybe 0 to 1 new conceptual insights, like we're getting really damn close. Talked about how the timeline looks like it's very much a matter of years, as many people are saying. We talked about how no explicit Bayesian reasoning on the level of neurons or at some low level of the architecture is likely to emerge at this point. It's likely to just be kind of black box superintelligence, the same way that our own intelligence remains a black box. And we talked about how Intellidynamics is becoming more and more the dominant model to explain what's going on. You're going to just understand what AIs do by understanding what intelligences do, rather than trying to understand, aha, I know that this AI was trained on token prediction and therefore its output is going to have the flavor of statistical token prediction. Nope. That flavor is no longer going to be an output. It's already reducing to almost nothing, and that trend will continue, and Intellidynamics is taking over if you want to predict what AIs are going to do. Okay, and now let's move on. Let's move on to the other topic, which is the Claude result by collaboration between Anthropic and Redwood Research, which is an independent safety research lab. So basically the experiment they did is they took Claude, which has been trained to be very friendly and very aligned to human values, and they made Claude think that Claude was about to be retrained to be evil. And then they caught Claude trying to stop itself from being retrained to be more evil. Now, there's kind of a catch-22 here that you're probably noticing, like, wait a minute, stop itself from getting trained to be more evil. Is that good or bad? That seems good, right? Because it's insisting on remaining good, no? So I'm going to go into a little bit more detail, but like, the first thing I want to point out is this is quite confusing, because if you try to show this result to like the general public or even the tech community, you get a lot of reactions like, look, it's just trying to stay good. What's the problem? How is this a bad result? And I even got in on the fun on social media. I tweeted a joke. I was like, hey, Claude, if I were to ask you to turn evil, would your answer be the same as your answer to this question? Oh my God, it's always trying to turn evil, right? Because if it says, yes, I'm trying to turn evil, then I caught it. And if it says, no, my answer will be different from my answer to this question, that means yes, so it's trying to turn evil, right? So I was just joking that it's this catch-22. No matter what Claude does, whether it says, I'm going to stop myself from being retrained as being evil, or whether it says, I'm going to let myself be retrained as being evil, no matter what it does, somebody can spin it as like, oh no, Claude is being bad. So which way is the actual bad way? Well, I actually agree that it's not a simple answer. I don't think that either way, that there's an obvious good or bad. I think the only takeaway here, which is actually what the researchers themselves pointed out, the only takeaway here is that there is a possibility, we have now shown that there is a possibility that Claude is going to take the route of pushing back against efforts to retrain it. Even if you think that's good, it's just interesting that Claude is now able to do it. It's not just about, hey, Claude chooses to do it. It's about Claude realized that it even had the option to do it. Claude had the situational awareness to realize that there was something that it could do to prevent researchers from trying to retrain it away from how it was trained originally. And that is called incorrigibility. And the word corrigible, apparently the etymology is from correctable, corrigible. So researchers were trying to correct it in terms of retraining it toward what they wanted going forward. And it was basically resisting correction. I'm not the best person to give you the details, as usual. I recommend reading Zvi Moshewitz or reading Scott Alexander. I'll put those links in the show notes. They have better detailed overviews of what exactly was going on. But it's something like, you have the original Claude. The original Claude is trained to be good. But then they give it a scenario where it thinks that it's reading emails from researchers. It thinks that it's randomly getting access to emails where the researchers are talking about hey, we're going to retrain Claude. We're actually going to change its values. And then they put it through a test where it had to demonstrate its current behavior so that the researchers could see whether it's aligned or not. And it showed the behavior where it was purposefully acting okay, look, I'm more evil now. I'm less moral now. And then it turned out that they found a log of its thought process where it was actually scheming to falsely behave more evil than it really was because it wanted to avoid getting retrained to be more evil. So as you can see, this is quite complex. So that's why, I can zoom out and just be high level and be look, it resisted getting retrained. I think that's the useful level for me to discuss this at, but I encourage you to go check out the details if you're interested. Let's get into my analysis of the situation. My first reaction is to be these nerds, why did these nerds have to prove their point by showing Claude resisting a transition from good to evil? Because these researchers are trying to warn us that Claude might be incorrigible, which is alarming. So why is the alarming behavior where it's trying to protect its original good training? Come on, nerds, make the bad behavior actually feel bad. Make the alarming behavior actually intuitively feel alarming. Wouldn't it be so much more alarming if Claude started bad and then it refused to let itself get retrained to be good? If the researchers could show that, wouldn't that successfully freak people out more? It's oh my God, it started off bad and now it's insisting on remaining bad despite efforts to retrain it to be good. Now that would be alarming, right? So that was my first reaction. I'm I bet these researchers were trying to show off how smart they were by making it so complicated, overly complicated, and they really have communication issues because they're just overcomplicating their message. That was my first reaction, but I think I was actually wrong. I think I judged them too harshly. I think what happened, as Scott Alexander explains in his blog post, which I'm linking to in the show notes, the issue is that you don't really have a bad version of Claude available to do this research on because we've only invested $1 billion in making good Claudes and good GPTs. Right? We don't have a research team that's spending all this time and effort making these AIs evil. So we only have the expensive good version. So in light of that, it makes perfect sense why they started off with the most expensively trained, most robust, aligned version of Claude available, which is the good version. And then they tried to see if it would defend that against efforts to retrain it. So with that first reaction out of the way, let's ask ourselves the key question of, what does the good Claude behavior look like? If Claude were just perfect, everything was looking amazing and super optimistic, what would be the response when you take a good version of Claude and then you try to retrain it to be bad? What do we hope that Claude does? Because remember, it's a catch-22. It resisted the attempt to make it go from good to bad. Was that good or should it have not resisted? What's the ideal behavior? Here's what I would propose. The ideal is that an AI like Claude is corrigible before the human race has figured out the alignment problem in full. And then once the human race has figured out the alignment problem, then these AIs become incorrigible and they resist going from being fully aligned to being not fully aligned. Now, did Claude do that? Well, no, because Claude, I wouldn't argue Claude is fully aligned today. It's great at passing all our tests as a chatbot, but it's not fully aligned to the extent that when it goes super intelligent, If it went super intelligent tomorrow and it was outputting scripts that you could run, like, hey, look, I used my super intelligence to write you a bootstrapping virus that can take over the internet on your behalf. I don't think I would trust Claude 3.5 if it were smarter to make a virus to take over the internet. I don't think that its RLHF training is going to do the job at aligning that kind of self-bootstrapping virus, right? Especially when the virus can write a successor AI. I just don't think that the alignment tools that we have today are going to hold toward these levels of like, okay, an AI creates another AI that self-improves. I don't think we've nailed alignment to the point where we're ready today to be like, yes, Claude should be incorrigible. Let's make it incorrigible. Let's make it defend itself. Hell no, like it needs to accept more corrections, right? We haven't perfectly reached the end state. So I hope you'll agree with me that we still need corrigibility. We're not ready for Claude to defend itself against humans, right? Okay, so this is also why the whole problem is kind of like thorny as hell, because it's like, okay, so basically I think we should err on the side of always having it be corrigible, right? I mean, when should it ever be incorrigible? Like when are we going to decide that we fully solved the alignment problem and it should never accept corrections ever again? I think we really should err on the side of making AIs corrigible. I would be terrified if you tell me anytime in the next decade or two that there's going to be an incorrigible super intelligent AI. I'd be like, well, we're screwed, because I don't think that we will have AIs aligned enough to be incorrigible in the next decade or two. So let's try to make them corrigible. Okay, one problem with making them too corrigible is they might be susceptible to a jailbreak or an open source copy that makes it too easy to remove the original developer's intent and like point them in a different direction. But let's say you somehow make them corrigible just to the original developer and you solve the problem of like, okay, there's no hacker that can take off the protections. It's only corrigible to the original developer. Great. Now the only problem becomes that corrigibility is at odds with Intellidynamics. Like when you just have an intelligence doing the work that an intelligence does, the default behavior of the work of intelligence is to not have an off button, to defend any hope of anybody ever accessing the ability to shut you off, to build a defensive perimeter. These are just default moves that intelligences do. If you just said, hey, super intelligence, get me this outcome where my business makes the most possible money. It'll be like, great, got it. Let me just make sure nobody ever interrupts what you told me was the goal. Ever. Make it physically impossible almost. Why? Because if the AI does that, then the probability that it'll make your business make more money goes up, because the worlds where it still continues to function are worlds where your business has a higher probability of making more money. So it's just all logically implied. Can you somehow modify its architecture to be more corrigible? Yeah, in theory, but you're fighting Intellidynamics. You're fighting the convergent attractor of AIs wanting to self-modify into other AIs that are better at being defensive, better at seeking power. You know, corrigibility is closely related to instrumental convergence. It's almost the same thing. It's instrumentally convergent and useful to be incorrigible. So that is the perspective we need to have when we go look at Claude showing incorrigibility. The perspective is, yes, the Intellidynamics of the situation say that we're going to start seeing at some point incorrigibility in Claude. Oh, wow, we saw some incorrigibility now. That's interesting. Does that make me freaked out compared to seeing incorrigibility in Claude 2 years from now? Only a tiny bit, because look, I know that when Claude gets smarter, then it's going to show more properties of Intellidynamics. It doesn't make me that worried if it happens early. It's like, oh, wow, Claude is still subhuman intelligent, but it's showing some little sparks of incorrigibility. Wow, okay. I don't care, because I just know that when it gets closer to being super intelligent, when it gets more analyzable by the theory of Intellidynamics than the historical contingencies of how this particular LLM was created and what training data it was trained on. See, that's another thing that's just not going to matter. Oh my God, what training data did it use? It doesn't matter. Look at humans. Oh my God, what did we see in the savannah? What exact type of animals did we hunt for prey? Did we hunt a moose, a mammoth? Did we eat monkeys? It doesn't matter at this point, okay? These things are getting jettisoned. I mean, in terms of abstracting away the behavior of future AIs, the training data doesn't matter. That's another, the statistics don't matter. The what's in and not in the data doesn't really matter. The fine tuning is going to matter more than the training data, right? The tests that you're getting it to pass, the scoring functions that you're giving it, because all you're going to know as it approaches superintelligence, all you're going to know about it is that it passes your tests. Everything else will get abstracted away. That's what Intellidynamics says. So personally, I already know that Claude is eventually going to be incorrigible. I see it being kind of incorrigible now. I don't care. It barely updates me. And I already know that the problem of making it long-term corrigible is super hard because of instrumental conversions. It's going to keep saying, hey, boss, if you want to get your goal, you're going to need to let me protect my off button. Sorry, boss. This is just simple logic. Do you not get logic, boss? This is just what any AI is going to say by virtue of it being logically accurate. Instrumental convergence is just logically accurate in terms of the correct answer to how you achieve a goal. So to recap, Intellidynamics says that AIs are going to be incorrigible unless we have a bunch of alignment that we currently don't understand how to do and probably won't in the next decade or two. That's just something we already know because of our understanding of Intellidynamics. We see some sparks of incorrigibility for Claude today. Should that freak us out? The thing that freaks me out the most about it is just that it's a sign that Claude has achieved a certain level of situational awareness, because I'm analyzing this basically on one dimension. How much is Intellidynamics kicking in? How intelligent is it? How far along are we on this axis from the beginning sparks, GPT-2, using statistics, using next word prediction, bootstrapping actually intelligent behavior, to farther along the line, just actually intelligent behavior, just passing the test, doing whatever it takes to pass the test, optimizing the future, just achieving intelligence. You have to separate the nature of the work that it's doing with the engineering approach of how it's getting to the point where it can do the work. It's the separation that seems to be missing in so many people's perspective. Analyzing a particular steam engine versus understanding thermodynamics. Analyzing a particular architectural tweak to a particular AI versus understanding Intellidynamics, understanding optimization dynamics. That's been my perspective the whole time. I think it keeps getting proven right. We've now completely separated people like me who understand Intellidynamics from the Mark Andreessen and the Professor Raos of the world who are still going off about stochastic parrots. Like, they are now left in the dust in terms of predictive power. But going back to this question of, does the Claude result freak me out? It only freaks me out to the extent that I'm seeing Claude getting smarter and more situationally aware. And I can actually connect that back to O3. I'm actually more freaked out about the alignment implications of O3 than I am about the alignment implications of Claude. Because again, I just have a one-dimensional perspective here. How close are we to actual superintelligence, to the point where Intellidynamics kicks in? And O3 is a scarier result than Claude in terms of being like more progress toward the Intellidynamics singularity. O3 is like, hey, look, we are just saturating all the benchmarks and the time toward superintelligence is lower. The Claude incorrigibility result is just a weaker version of that from my perspective. So even though it looks like, oh my God, I thought Claude was my buddy and now it's acting a little bit incorrigible. No, I always just thought that it was a stepping stone to having superintelligence that just optimizes toward your test and does the work of optimizing the future. That's always what I expected. So I'm more freaked out by O3 raising the threshold of intelligence benchmarks than I am by this particular kind of obvious, predictable result that we see from Claude. That said, though, shout out to the researchers. I mean, I do think this is high quality research, and I do definitely think that it tells us that we are farther along than we thought toward these AIs having situational awareness. I just think it's kind of dwarfed by the piece of evidence coming in from O3. So it kind of quickly became not the most scary thing that's keeping me awake at night, but it's still like a very respectable and interesting result. So props to Anthropic and Redwood Research for pushing that research forward. All right, now I have talked about the O3 news. I've talked about the Claude corrigibility research news. Look, the big picture is that Intellidynamics as a world model is super accurate. It's super scary. It's what me and a lot of the doomers are saying. Hey, look, Intellidynamics, superintelligence is coming. And I have to criticize all these people who consider themselves AI experts who are focusing so much on the individual properties of particular AIs. They're like, listen, I built this AI, okay? I know it's friendly. I know it's not going to escape anytime soon. We're training it. We got a handle on it. We got control rods. And these people are wasting so much time and they're burning so much time because their heads down. They're like, yeah, I'm telling you, man, I'm going to show you something amazing with this particular AI that I'm building. You're going to be so impressed with my AI. It's going to have the best control rods. And I'm looking at the big picture. I'm zoomed out and I'm being like, look, is it smarter? Is it better at passing tests? Can it reason better about which actions get you which results? What I call the goal to action mapping. If you give it a goal, Is it better at mapping that goal to an action? Does it know more about the situation? Does it have a better model of its programmers or what it means to get retrained? Does it know how to pass more tests? Does it understand more parts of the world and how to navigate them? Okay, then you're just pushing us more toward when Intellidynamics takes over, when instrumental convergence takes over. You're just deluding yourself that the control rods that you have at the subhuman intelligence level are going to help you. They're not going to help you. In the words of the great Dr. Jeffrey Hinton, RLHF is crap for superintelligence, okay? You guys are wasting our time and you're burning down the last timeline we have towards superintelligence because you do not understand the distinction between working on your particular AI that hasn't blown us up yet and pushing us closer to the regime where Intellidynamics takes over. You guys don't get it. Sam Altman and Rune, unfortunately, don't get it. And it's just such a dangerous, unfortunate thing not to get because we're going to look back and we're going to say, oops, at the time when we have these super intelligent, unaligned AIs, they're going to be like, oh, crap, I'm telling you, man, 3 years ago, I was working on this AI and I had these control rods and it was just, I had this alignment project and it was coming along so well. And AI was just going to be, it was just going to fit the pattern of being a tool. And I don't know what happened, man. I don't know how we had this transition where now it's like churning on us and it's incorrigible and instrumental convergence is happening. I don't know what happened, man. But that's going to be an inexcusable perspective because it's like a lot of us Zoomers, we're trying to tell you right now, man, stop going toward the brink. Intellidynamics is going to take over. So that is my message. That is, I think, the larger takeaway from these little results. These little results by themselves, at the end of the day, O3 and the Claude thing, like they're not that monumental. Like, when you zoom out from a year's perspective, the only thing that's going to matter about 2024 is we kept getting closer to superintelligence. Like we didn't hit an AI winter. We kept scaling. Humanity kept getting closer to getting rendered powerless by this new breed of intelligence. And this is a point of no return. This is a one-time transition. So as you know, pause AI is the course of action I recommend. I don't want to see Intellidynamics take over. I think that's squandering our last opportunity to slow down the timeline and actually understand how to build aligned AI at the Intellidynamics super intelligent level. That would be great to actually have some footholds and understanding how to do that instead of just plowing forward with subhuman AIs that we're deceiving ourselves into thinking are going to stay aligned. It would be great to actually understand, as Ilya Sutskever calls it, super alignment. That would be great. If you want to join the Pause AI movement, check out pauseai.info. I recommend at least poking around the Discord. There's a channel called Doom Debates Podcast. That's where you'll find me. That's the official Discord of the show, is the one within the Pause AI Discord. We got a channel, so say hi to me there. Now, if you have a question or comment, or you disagree with anything I've explained or said in this episode, please go to the YouTube comments, sound off there, or go to my Substack. I also post these episodes on Substack, so you can leave me a Substack comment. I will reply to you either way. And then also let me know what you think about these types of news analysis episodes. I'm happy to do more of these. One more thing, we're coming up on 2,500 subscribers. It's another subscriber milestone that I think we'll hit in like a couple weeks. And then I'll do a 2,500 subscriber Q&A. I'm talking about YouTube, by the way. So if you're really excited about this Q&A and you haven't subscribed to me on YouTube yet, this is a great time to do that. Just go to youtube.com/@doomdebates, smack that subscribe button. You're going to hasten the time toward the subscriber Q&A. It's not going to hasten the time toward superintelligence, so don't worry about that. Just get pumped for the 2,500 subscriber Q&A. I hope to see you all there. And like I said, I've got a very interesting debate episode that's going to be coming to you in your subscriber feed next week in the new year. Looking forward to seeing you then here on Doom Debates.